The runout tolerances now. What is runout? It's actually a general term that applies to both circular and total runout. Then what is circular runout? It is the condition in which each circular element of a surface is at a zero variation relative to a datum axis or axis of rotation established from the datum reference frame. What is total runout? The condition in which all elements of a surface are tangent plane or at zero variation relative to a datum axis or axis of rotation established from the datum reference frame. Here all elements of a surface are tangent plane. Each circular element is circular runout. The circular runout tolerance zone or is two concentric circles as shown in the figure right side. The middle there are two concentric circles, and for the drawing in the left side, the feature must be within two concentric circles 0.05 apart relative to datum features A to B. This circular runout can be applied to any feature that creates a circular section or to a surface perpendicular to the axis of revolution, the surface which creates a circular cross section. It controls location, orientation, and circularity when applied to diameter of a cylinder. Total runout tolerance zone. There are two concentric cylinders as shown in the figure right side in the bottom. The feature for the drawing in the left side, the feature must be within two concentric cylinders 0.05 apart relative to datum features A and B. It can be applied to constant. It is applied to constant diameter cylinder or a surface perpendicular to the axis of revolution which has a concentric diameter. It controls location, orientation, and cylindricity when applied to diameter. Surface controlled by runout tolerances. You see datum axis that is established from the datum feature, and another two surfaces which are perpendicular to there are four surfaces. In fact, they are perpendicular to the axis of revolution. The surface at right angles to the datum axis, and there are four surfaces, and one is a datum feature, and three surfaces are established constructed around the about the datum axis. Runout tolerance syntax. The circular runout of the feature must be within 500 relative to multiple datum features A, B. And in the second symbol, the total runout of the feature must be within 500 relative to datum feature A and B. Total runout tolerance zone. This is on the drawing. You see the total runout of 0.05 O2 related to datum A. This means that there is a 0.02 mm tolerance zone along the circumference of the bigger diameter, and the datum axis A is established in the start part. Then again there is a 0.02 tolerance wide tolerance zone applied to the entire total surface. The entire surface must lie between the specified runout tolerance zone 0.02. The part is when the part is rotated 360 degrees about the datum axis, and the two indicators shows is placed at every location along the surface in a position normal to the true position. And again each feature each feature, I mean surface of the bigger dia and surface of the small dia, which is a data feature, a simulated data feature, and must be within the specified limits of size. And runout tolerances, the circular and total runout controls are very similar to circularity and cylindricity. The main difference is that runout controls are always related to datum of the feature, datum of the part, feature of size, datums of the part. The circular runout requires checks at each cross section of the part. If runout tolerance is less than the size tolerance, note that this is very important for solving stuck-up problems. If it is less than size tolerance, it refines the form as well as controls within the FORM form as well as controls with the acceptable error related to datum features. With the acceptable. If it is greater than size tolerance, it controls only the acceptable error relative to data features. Runout tolerance can be considered as a surface to axis control. If applied to the surfaces perpendicular to an axis of revolution, it controls the wobble, circular runout, or concavity and convexity, total runout. And runout tolerance summary. The circular runout as well as the total runout requires datum reference always, even though it is similar to circularity and cylindricity, which doesn't need datum reference. But here the runout tolerances requires the datum reference. It controls surfaces and axis and medium plane, and total runout controls for perpendicular surfaces only. Whether it can use MMC or LMC? No. It controls surfaces and median axis, but doesn't use any MMC or LMC modifiers. Thank you. Thank you for watching this video.